Hello and welcome back, Pre-Calculites. We're doing Day 2, Section 2.2, Applications of Power Functions. Hopefully you have your handy-dandy note sheet. This is what we're going to be filling in today. And applications, that's what we want to get to with mathematics. You learn all of this abstract stuff, but if it's not used for anything, what good is it? So this is the point we're trying to get you to. Now, hopefully you remember from yesterday your different vocabulary. What is varying directly? What is varying inversely? Proportional, inverse proportional, and so on. So you might want to have that sheet handy as well, your notes from yesterday. So let's start with the first problem with windmills. Windmill power, that's becoming increasingly popular now, where the wind turns the turbine. So here's the relationship they give you. They say the power P produced by a windmill is proportional to the cube of the wind speed. If a wind of 10 miles per hour generates 15 watts of power, how much power is generated by winds of 20, 40, and 80 miles per hour? Make a table and explain the pattern. When you look at this, it looks like a lot of information, and it is, but if you pick it apart, it's very simple. Now, when they say make a table, you know you're used to dealing with x's and y's. So the very first thing to begin your table is you need to know which variable is going to be like your x and which one is going to be like your y. Remember, y is output. The x is independent. It can change, but whatever it changes to changes the other ones. So it's pretty easy to see in this one, the wind is going to change and it's going to affect how much power is produced. So I'm going to make my table, and notice V I put on my x column. That's my wind speed. That's my x's. That's my changing variable. P is the output, the power. So that goes in the right-hand column. That's my y value. And hopefully from yesterday you also remember the different types of lingo. Like in this case, we're going to be using is proportional in a minute. When you go to do a word problem, always define what your variables mean and know what is going to represent your x and know what's going to represent your y's. Take a minute and write it down. Don't just try to go to the equation. So power P, they give you that variable, produced by a windmill is. When I first start picking it apart, I see P and I see is. From the basic translating math into symbols, you know you're going to have a P equals. That's what P is means. Proportional to the cube of the wind speed V. Well, the cube of V. All right. Well, how you represent that? Well, that's just V cubed. It's after the is, so it's going to go on the right-hand side. So like I said, I'm just taking this, picking the words apart. Now, proportional to, how do we incorporate that? Well, proportional to, if you remember from yesterday, y is proportional to x means y equals kx, where k is a constant. So this case, if it's proportional to, the k goes there right before the v cubed. So p equals kv cubed is our basic formula. It's not enough to start solving anything, so we're first going to have to find k. And they gave us that v is 10 and it causes p to be 15. So we're going to use that in order to find the k. So we're going to plug in a 10 for the v and a 15 for the p, and we're going to solve for k to get our formula. This computer's slow here. Here we go. So when we solve this out, we're going to have 15 equals 1,000 K. So to solve it, we just divide both by 1,000. So we get 0.015 is equal to K. Plug that back in, and we have a formula that we can generate all types of values for. So the formula we're going to have is P equals 0.015 V cubed. Now then, all you have to do to solve it is to complete the table, just put the given values of V into the formula to generate those values. So we're going to put a 20 in for V. So we'd have, for instance, 0.015 times 20 cubed. You can take my word for it, that's going to be 120. When you put 40 in for V cubed, you're going to get 960. And if you put 80 in, you're going to get 7,680 watts of power. So you've completed that. They want you to kind of look at the numbers too. And since the pattern is a cubic, the power produced will increase a lot with only a small increase in the wind speed. So they're trying to get you to realize the fact that if you have a power function, it goes up very high very quickly or goes down low very quickly. So little changes in the x make it get really high or really low really high. That could be fun. Okay, so let's look at the next one, which is light intensity. Now you have this one as Velma and Reggie. They gathered data using a light intensity probe, and here's your table of data. I'm pretty sure that all of you know how to do a scatter plot. When I look at the X values, I notice they only go from 1 to 3, so I'm going to skip a space so that I have 0.5, 1, 1.5, 2, 2.5, and so on. Then on the y-axis, that one's going up to 8, so I'm going to count by ones there. Yes, I know I skipped the 4, but you know, you guys can make it out. I also know that that 5's out of place, but don't get the 5 out of place on yours. So when you plot those points, all you do is plot them, and you can see how that is going down very rapidly. That's a sign of a power function. So after you've drawn the scatter plot, the next thing they want you to do is find a power regression model. So is the power close to the theoretical value of a equal -2? Now y'all have done the quadratic regressions and the linear regressions and that, so you do this the same way. What you're going to do is you're going to input the table of values into your grapher for L1, L2. In order to do that, you're going to have to go to Stat and Edit and put those in. Then when you go to do the power regression, you're going to go to Stat and Calculate, and instead of scrolling down, I would scroll up to where you have A. It's A stat. I also like to put the vars in there. So I did stat calc A, power reg, P-A-W-R-R-E-G, L1, comma, L2, comma, and I like to put that Y1 in there because it will go ahead and put your equation right into the Y equals for you. So to get the Y1, you do vars button, which is right under your arrow buttons, arrow keys, and then you scroll the Y vars and then hit number 1 for function and number 1 for Y1. Then when you hit enter, you're going to get the following thing up on your screen. The thing. There it is. So here's what should show up on your screen. Power reg y equals a times x to the b. And the little a, that's your constant, by the way, 7.93, and the b is -1.98. That's the power. So if I was writing this into the function format, this is what I would write. Y is approximately 7.932, x to the -1.987, and it is close to the theoretical value of -2. Now, the next one's pretty easy. When they superimpose the curve, you just kind of have to look and see which points it goes through and draw your line. And then we're going to use that regression model. You're going to use that regression model to predict the light intensity. So the whole reason you find your regression model is to be able to make those predictions. So there's your graph, and then you're going to put your line through there if it decides to do it for me. It's really slow. I'm just too fast. That's what it is. Okay, to use the regression model to find the light intensities, 1.7, basically what you're doing is you're going to put a 1.7 in for the x, but if you have that on your graphing calculator, all you have to do is go to second and then trace. That'll take you to the calculate menu, and you'll hit number 1 for value, and then you'll hit 1.7 and enter, and it'll give you that. And you do that same thing for 3.4. and you'll get those two values. So let's hope that it does that. So if you do that on your graphing calculator, go to the calculate menu and value, type in 1.7 and enter. You should get 2.76 out for the y. And if you put in the 3.4, you should get 0.697 in the y, respectively. So there you go. There's some application problems. You should be ready to roll for the class activity tomorrow. Thanks a lot. Bye-bye.